Alright, on the end of the class on Saturday, we left off on this problem, where you had plugged in a bunch of values into this function, f of x equals x over x minus 2, and the next task was to make a graph. And we were a little stuck on that point, we weren't quite sure of the process, so this video is to help you figure out exactly what you were supposed to do to turn that function into a graph in front of us. And we know that for any function, the rule given is what defines the height of the function. Right? What are the heights of the function? What are the y values? Right here are the y values, but really these are the heights. When I plug in an x value, right, what comes out? What are those heights that I'm looking at? And so in the xy chart, it's important that we choose a set of values that gives us the best opportunity to see the overall behavior of the graph. So we want to pick things that follow one after the other. We don't want to pick at random. Like I don't want to pick 2, 6, 9, 15. That doesn't really work. So I generally start minus 3, minus 2, minus 1, 0, 1, 2, 3. See what that gives me, and then if I need some more points, I'll add them later on. The ability to know when you need more points is also something that we have to work on. But for right now, those 7 should be where you start for each graph. And then if you don't get enough information, then you look at things beyond those 7. Once I've taken those 7 and plugged them in, you can see the process as I plug them in, and then I've recorded what the point would look like on the right. The most interesting part of that is what happens here. Right? When you plug in 2, you get something that's undefined. Right? You get 2 over 2 minus 2. Right? That's division by 0. When it's an undefined height, it's not in the domain. And we know it can be one of two things. We've talked about being one of two things. It's either going to be a hole in the graph, or it's going to be an asymptote. And what you wouldn't know, but which tends to be true for mathematical functions particularly, is that the asymptote is the far more likely occurrence there. Okay? It's far more likely that we have an asymptote. We'll eventually learn why it is that there's an asymptote there and how we can identify it from the function itself. Once I've done the initial xy chart, my next job is to plot those points on the graph. And so you can see I've plotted the 6 of the 7 points on the graph, and I've also plotted what I think happens at 2. Right? To me, we have an asymptote here at x equals 2. And we have some idea of what the graph looks like. On the left, we'd expect those blue points to be connected to one another, and on the right, we'd expect that single blue point to do something. But there's not quite enough information. And I might like to know what occurs in this area, or what occurs in this area. Right? Because those areas would tell me a little bit more about what I'm doing around the asymptote. And I can get a better view just by taking a point, right, that's in there. If this is 1, and this is 2, and this is 3, the first extra points that I should check are what happens at 3/2, which is on the left-hand side of the asymptote. And the answer is we're down here at -3. And I should check what happens at 5/2, which is on the other side of the asymptote, and it turns out we're at +5. At this point, the pattern seems to be pretty clear. We seem to be going down from the left, and we seem to be coming up from the right. And that we'd be pretty confident that's part of our graph. And so now I might need a little bit more information, right? What happens as I get outside of this area? Let's add a couple more positive points. So when x is 6, the height is 3/2. So we'll add that in. And when x is 10, the height is 5/4. So those heights seem to be leveling off. And when x is -10, the heights are 5/6. So we're over here. And we can see the heights seem to be leveling off to something not quite getting there, right? What are they leveling off to? Well, they're leveling off to this horizontal value, and they're doing it on the same side, right? They're both leveling off to the same area. And so it turns out, and you can notice I actually drew this incorrectly, so let's drop that down a little bit. Right? 6 was supposed to be 3/2, and I made it 5/2, so we'll drop that down to 3/2, and we'll drop this down to 5/4. And now we can see that in between those two graphs, there seems to be something else of importance here. There's a horizontal asymptote, right? Because we're getting really close to that value of 1 on either side. We can see that from the points, right? 10, 5/4, a little bit above 1. -10, 5/6, a little bit below 1. So this is a great picture of x over x minus 2. Not all of the information that you put on that graph is necessarily the easiest to come up with. It is a little bit of a guess process at this moment because I'm asking you to pick more points that you want to test. If you still don't feel like you can come up with the shape after you've done 6 or 7 points, the next thing you need to do is test more. Okay, just keep coming up with more heights. Keep trying to figure out what the patterns look like. This is about as complicated as it can get from this point, right? Just by plugging in points to the function. You'll find that some of the other examples in the homework are much simpler in terms of what the behavior looks like, while others will require you to plug some points in particular areas to figure out what the overall curve looks like.